Hello, my name is Nicholas Wood. This is Nicholas Polito and Nicholas Ramish. And this is Anissa Harkarik, our fearless leader. And we are Team 3NA. Today, we will be presenting our drone project. Since the 1930s, meteorologists and weather enthusiasts have used weather balloons to make educated assumptions about weather conditions. These hovering weather stations are equipped with instruments such as thermometers, barometers, and hygrometers to measure temperature, pressure, and humidity, respectively. These readings are used to help forecast everyday weather, but there are many disadvantages, including some ethical dilemmas. A weather balloon trip takes about 2 to 4 hours, so when you finally receive that data, it is hours later, which has given Mother Nature enough time to change her mind and take the weather in a completely different direction than what it was going before. The balloon also pops due to the atmospheric pressure once it gets high enough, and the payload then floats back down to Earth. Sometimes this payload can be difficult to find, and occasionally the balloon itself is unable to be found because it has detached itself from the payload. Now, not only was your balloon launched for nothing, but you have now also left litter in the environment. There is also the risk of the parachute from the payload not deploying properly. Now, this payload will not only be damaged, but this heavy box could hit somebody or something on its way down that it shouldn't. This technology has not really changed at all since the 1930s. They still use latex balloons attached to a container that is often a cardboard box to hold the sensors. With the rise in technology over the past 80 years, isn't there a better way to complete this task? The answer is yes. Introducing the Dronecaster. Now, what is a Dronecaster, you ask? Well, it's a combination of the word drone and forecast. The idea comes from a weather balloon. Weather balloons start collecting the data as soon as they are launched from the ground. In fact, everything above 3 meters high is considered upper air data. The Dronecaster will be controlled manually to go up into the sky and return to the ground while reading and collecting this upper air data. It will be equipped with all of the same sensors as a weather balloon to measure the temperature, pressure, humidity, and also the altitude. These sensors and instrumentations are lightweight, so even if worst comes to worst, and the drone does end up crashing, it poses less of a threat than a large payload off of a weather balloon. It's also going to be falling from a slightly smaller height, which means it will gain less speed, causing less damage. The drone will then store this recorded upper air information on a drive that is on board. This information can then be used by meteorologists to more accurately predict weather and its patterns. Since this is a drone, it will move much faster than a balloon, and you won't have to wait for the vessel to pop. You can get multiple readings in the time it would take a weather balloon to go up into the air, pop, and let the payload fall all the way back down to the ground. Another advantage is that it can be reused as much as needed, whereas a weather balloon cannot be reused. It requires a new balloon for every single use. The recent events that have devastated Texas and Puerto Rico really inspired this project. Hurricane Harvey and Hurricane Irma destroyed and flooded homes, injured and killed people, and left most people in Puerto Rico without power for 6 months. With faster technology for recording air data and for forecasting was available to them, such as the Dronecaster, these residents of these areas may have known better as to when they were supposed to evacuate, so that they wouldn't be caught in all of the disaster and could be safely in some other area. We can no longer aid those people that have suffered in the area with the Dronecasters, but it can help those whose homes have the potential to see this type of storm again in the future.